What if reality isn't just made of particles and forces, but also swirling patterns in a dimension we can't even see? What if tiny quantum tornadoes are constantly forming, not in physical space, but in the very motion of matter? Sounds like sci-fi, right? But incredibly, scientists have now experimentally observed quantum tornadoes in momentum space, unveiling a bizarre new facet of reality that will blow your mind. For most of us, when we think of a tornado or a whirlpool, we imagine a swirling vortex of wind or water, a visible phenomenon happening right here in our everyday three-dimensional world. But the quantum realm, the universe's smallest scales, plays by radically different rules. Particles like electrons don't just have a position, they also have momentum, a combination of their mass and velocity. And in the quantum world, this momentum isn't just a simple number, it's a property that can be described in its own abstract space. Welcome to momentum space, a fundamental concept in quantum physics that describes the motion and direction of particles, rather than their exact location. It's like a map, not of where things are, but of where they're going and how fast. For a long time, physicists theorized that just as vortices can form in real physical space, they could also exist in this abstract momentum space. Imagine not seeing a tornado of wind, but rather a tornado of electron motion, a swirling pattern in the collective directions and speeds of countless tiny particles. This idea was first proposed almost a decade ago by theoretical physicist Roderich Mosner, who described them as resembling smoke rings of quantum motion. But proving it experimentally? That was the monumental challenge. Enter the brilliant minds at the universities of Würzburg and Dresden, led by Dr. Maximilian Unzelmann and his team. They set out to find these elusive quantum tornadoes. Their target? A fascinating quantum material called tantalum arsenide, or TOS for short. This material is known for its exotic electronic properties, acting as a topological semimetal, which is a fancy way of saying its electrons behave in extremely peculiar and interesting ways. To detect these hidden swirls, the researchers used a highly advanced technique called angle-resolved photoemission spectroscopy, or ARPS. Think of ARPS as a supersensitive camera for electrons. They shine X-ray light onto the tantalum arsenide sample, which then ejects electrons. By carefully measuring the energy and angle at which these electrons escape, they can reconstruct a precise, three-dimensional map of the electron's behavior in momentum space. It's almost like taking a scan of the electrons' dance moves, rather than where they're standing. And what they saw was truly astonishing. Through meticulous analysis, they confirmed the existence of topological vortex lines of orbital angular momentum, essentially, those quantum tornadoes, swirling in the momentum space of the electrons within the tantalum arsenide. These weren't just random fluctuations, they were distinct, stable vortex structures, perfectly matching theoretical predictions. It was like finding an invisible, fundamental whirlpool in the very essence of how particles move. So, why is this such a big deal? What does discovering quantum tornadoes in momentum space mean for us? Well, the implications are profound, cutting across fundamental physics and future technology. First, on a fundamental level, this discovery confirms long-standing theoretical predictions and deepens our understanding of topological phases of matter. These are exotic states of matter where quantum properties are protected by their topology, meaning they are incredibly robust and resistant to disturbances. Understanding these topological properties is crucial for unlocking new physics. These momentum space vortices are a new class of such topological features. Second, and perhaps more practically, this breakthrough opens up exciting new avenues for quantum technologies. The field of orbitronics, for instance, aims to harness the orbital motion of electrons, which is related to these vortices, for information processing. Imagine computers that use the swirling patterns of electrons' momentum, rather than just their spin or charge, to store and process data. This could lead to incredibly energy-efficient quantum components and revolutionary new ways to build quantum computers and sensors. It's about leveraging the inherent strangeness of the quantum world to build technologies we can barely even dream of today. Third, this research offers a powerful new tool for probing quantum materials. By being able to map these momentum space vortices, scientists gain unprecedented insight into how electrons behave in complex quantum systems. This allows them to test theories of condensed matter physics with new precision and discover entirely new phenomena that might have been hidden before. It's like adding a brand new, ultra-sensitive sense to our scientific toolkit, allowing us to perceive the universe in a way we never could before. The journey to uncover these quantum tornadoes was a testament to human ingenuity, from theoretical predictions that seemed almost impossible to verify, to developing cutting-edge experimental techniques that could peer into the abstract realm of momentum space. It reminds us that the universe, especially at its smallest scales, is far stranger and more wonderful than we can possibly imagine, constantly revealing new layers of complexity and beauty. What other hidden tornadoes or unimaginable structures exist in the quantum fabric of reality? This discovery is just the beginning. The universe is waiting to surprise us again and again. If you found this dive into the quantum weirdness as fascinating as I did, hit that like button, share this video with a friend who loves mind-bending science, and definitely subscribe to the channel for more cosmic explorations. And I want to know what you think. What's the most surprising quantum phenomenon you've ever heard of? Let me know in the comments below.